In this video, we're going to look at another example of finding the general antiderivative of a given function. So in the previous video, what we talked about is almost thinking about this given f of x here as the derivative of our original f of x function, and what we're trying to find is the function capital F of x such that capital F prime equals f. And if we can find that, we know that capital F is an antiderivative of this given function here. So, what we also talked about is thinking about the processes that give us derivatives, and we're almost going to try to piece those together backwards to try to figure out what function, what capital F, spawned this as a derivative, okay? So what I'm seeing here is a function that's defined as a composition of functions, right? We have a constant multiple here, so that doesn't really play bearing on it, but we have a sine of negative 10x, so we have a function composed inside of another function. So what we're going to need to do in order to try to figure out what function spawned this derivative and what kind of brought it into the forefront, or into this question for us rather, I don't know where I'm getting these words from, what we're going to need to do is try to piece together the chain rule going backwards to see if we can come up with the capital F that gave us this, okay? So this is where the table that I make for chain rule kind of comes really in handy, because we can think about what comes where in terms of the chain rule and like what goes where, and we can kind of piece this together going backwards to see if we can figure out our capital F. So we know that when we use this chain rule notation here, or this table, we have to plug in the original inner function into the derivative of our original function, right? So this sine was the derivative of what was originally given as our outer function. Okay, we can kind of think about it that way. And this negative 10x got plugged into sine by the nature of the chain rule. So we had the derivative of the outermost function composed with, composed with this function, the original function of the innermost function. So we can kind of think, just in terms of this table, what are the other two missing pieces that we have here? Well, we know that if we have this negative 10x, this thing that goes beneath it is the derivative of that, which in this case is negative 10. So at this point, what we have is we have negative 10 sine of negative 10x, right? And well, what we see is that with the stuff that we have so far, this is what would result in the derivative of what we know. But this f of x is actually the derivative like what was given to us. So these don't match, right? Like the sine of negative 10x parts match, but this 3 and this negative 10 have something off. So maybe we have to do something with the constant multiples here in a second to try to get those to match up. But let's go ahead and finish the table off, because we need to know what did we derive to give us sine. So if we think about the trig derivatives that we know and have used a couple times over this semester, what we're going to need to see is we're going to need to ask ourselves, what did we derive to give us a positive sine? And we know that the derivative of cosine is negative sine. So if we want to take the derivative of negative cosine, this would give us a positive sign. Okay? So what we're seeing so far is that we're going to have a capital F function that kind of looks like negative cosine of negative 10x. All right, so this is kind of what we're thinking for f of x so far. Let's go ahead and write that down so we don't lose that. So we have something like this. And then remember, when we have this capital F, we always have to count for that plus c, that arbitrary constant that could be part of this original function that when we derived, it went away. Right, so we have to do this plus c here. So we have this as kind of an idea of what we're doing for our capital F, but maybe this isn't the actual capital F. We can check that by asking ourselves, what is f prime? Because if f prime matches with f, then we're going to get that f is actually our antiderivative and we can stop worrying. But what we see is that when we take the derivative of this, we're going to use this table we just constructed here and get something like this. So what we need to figure out is we need to figure out what constant multiple can we multiply into this to give us an f of x that gives us this thing. So that's what we need to start thinking about here for a second. So we know that right now this f prime does not equal f of x. Okay? So this is not our f of x that we're going to need to be concerned with here, but we can maybe change it through use of a constant multiple to get us something that would give us this as our derivative. So what we see looking at f of x and the derivative that it gives us versus the derivative we want it to look like, we see that the difference that we have is, in a way, we have a negative in front of here, right? So we need to multiply negative 10 by some negative number, right, to give us this positive 3 that we're looking for here. But then what we're also going to need to do is how can we multiply 10 by something to give us 3? And well, we know that if we multiply 10 by something like 3 over 10, the 10s will divide away because in the numerator and the denominator, right? So we'd be left with a 3. So maybe the constant multiple that we're looking for is something like, since we need to multiply it by a negative, we need to multiply it by negative 3 over 10. So this original capital F of x that we have that we thought would give us f of x if we derived it, maybe if we bring in this negative 3 over 10 into the mix as a constant multiple, maybe that would give us what our real capital F of x is. So we're going to ignore this one because it's not completely correct, but we're going to rewrite it in terms of bringing in that negative 310 into the mix. So we have capital F of x equals negative 3 over 10 times negative cosine of negative 10x, and then plus this arbitrary constant c. So now that we have something incorporating a constant multiple of negative 3 over 10 that we think should work, let's multiply negative 3 over 10 to this negative cosine of negative 10x here, and let's see what our f of x becomes. So we have negative 3 over 10 times negative cosine gives us a positive 3 over 10 cosine of negative 10x plus c. So now we have something else that we think that if we derive it, we could get something that looks like this as our derivative. Okay? So let's do a quick little chain rule check to see if we get that the derivative of this equals little f that we were given. So I'm going to use my table one more time. Let's see, I have some space right here. So let's do it over here. So what we have is this constant multiple we're going to leave off. So we know that we're going to multiply our derivative by 3 over 10. But we have cosine of something gives us negative sine of something. And the original argument is negative 10x, so we get negative 10. And this plus c, like we said, when we derive it, since it's a constant, it evaluates to 0, so we don't have to worry about it. But now, let's plug things in and multiply stuff that we need to. So we get negative 10 times negative sine gives us just 10 sine of negative 10x, right? So that after we use the chain rule, we get this. So we need to multiply this by 3 over 10, our constant multiple. So we get this. And then now, once we carry out this multiplication, we see that once we multiply 3 over 10 times this coefficient of 10 right here, that is multiplied to sine, or it's kind of like an amplitude of the sine function, actually not a coefficient of it. So once we get that, this divided by 10 and this 10 are going to divide away, so we're going to be left with 3 sine of negative 10x, which is exactly what our original function was given to us as. So this capital F of x that we found through use of constant multiples here is actually going to be the general antiderivative for this function that we had in question. So this one was a little bit more involved than the power rule one, namely because we had to look at the issue of the constant multiple that we need to bring into the mix that satisfied our capital F giving us this specific derivative. Because the original antiderivative we thought we had almost gave us the correct answer, but it gave us something that looks like this, and they didn't really match. These two didn't match together, right? So what we needed to do was figure out what number can we multiply our f of x by that we found here to give us a new capital F of x in a way that would actually give us this little f as a derivative. So, like I said, it was a little bit more involved, but through use of some reasoning and some multiplication of numbers, we're able to figure out what our general antiderivative is for this function.